Hey, welcome back, boys and girls. It's been a while since we've been on video here. So here is lesson 7.5, and this is factoring this ax squared plus bxy plus cy squared. And it's similar to what we did in class on Monday, but you'll notice that this trinomial right here has two variables. Remember, variables stand for a number, and they are the symbol is a letter. So you've got an x and a y, both, well, and an x squared, but you've got two different variables in here. When you have trinomials with that second variable, it's in this form right here. Yesterday we did ax squared plus bx plus c. That was it. But today's lesson, 7.5, is a little bit different here. But the factoring is, we're going to use the same method as when we factored and there was only one variable. So what we're going to do is, remember, the first thing is we're going to factor out any common monomials. And in this, there's nothing that they have in common. Not all of them have an x, not all of them have a y, not all of them have a number that is a greatest common factor. So there are no common monomials here. So in order to determine the correct factor pair, we're going to look at A and C. And you remember, this would be A and this would be C. And I'm taking that from this right here. So the first one, A, represents the number that would be with x squared, which in this case is just going to be 1. So we're doing A times C. And remember, C is going to be the number that is with y squared, which is 2. So we have a 1 and a 2. And when we multiply that, we get 2. So then we need to look at all the factor pairs for 2. So what are all the numbers? And this is a positive 2. So basically we have 1 times 2, or a negative 1 times a negative 2. Those are our two factor pairs that are going to equal 2. Then what we need to do is go ahead and look at this center right here. And then we're going to determine which one of these factor pairs would equal a negative 3. So if we were to add these up, 1 plus 2, we'd get 3. This would be negative 1 plus a negative 2 yields us a negative 3. So we're going to be using those two right there. So then after we have found the numbers that we need to use, the correct factor pair, which is those two, then we're going to go ahead and rewrite the polynomial using that factor pair. So, and if you recall, we did the FOIL method here, which I thought was quite helpful. I don't know if you thought. I hope you thought it was helpful. Kind of running out a little bit of room here. But first one here, we have x squared. And then remember, the O and the I are these two right here. And that makes up this part right here. This is the F, this is the O and the I, and this is the L. So we can go ahead and write in our F and our L because we already know what those are. Our O is going to be negative 1. And in this case, because this is an xy, we're going to put x and y. Remember that it is the O and the I that make up this second term here in this trinomial. And then our next one is going to be minus 2xy. Yesterday, or depending on whenever you're watching this, Monday, when we were doing this, we just put in x's, but in this case, it is labeled with the two variables x and y, so that's why we have to put the x and y. Okay, so we have our FOIL here, and now we're going to do what we were doing again on Monday, and also what we did in lesson 7. I can't remember what it was. It was last week's, the last lesson of last week, where we take, because we have a polynomial, we have 4 terms here. So we're going to take those two, and we're going to take those two, and we're going to factor those out by grouping them. So we're grouping them 2 together. So when you have 4, you can group 2 together. That was from a lesson last week. So we have x squared minus xy. And then we have negative 2xy plus 2y squared. And then we're going to factor out from each of these. So what do these have in common? What can we factor out? They both have an x, so we're going to take the x out. And remember, I don't know if this helps you or not, but you can think of it like dividing each by an x, and what are you left over with? Because you're taking the x out of here. You're taking one x out of each of these. So what would you be left with is what goes in the parentheses. So this would be x minus y. And then in this next one, what would they have in common? They both have a 2 and they both have a y. But I'm going to get rid of that negative, so I'm going to actually factor out a minus 2y. So essentially, I'm dividing each by negative 2y. And that's going to get me, that would cancel out, that would cancel out. So that ends up with an x, and then this would end up with a negative y. So I have factored these two by grouping them down to here. Now I'm going to also factor, because they both have these in common, which means I'm going to pull out the x and the y, because they both have those in common. And think of it, if you want, like you're dividing by these. That cancels out, that cancels out. You're left with an x minus 2y. And that's your answer. Remember, we talked in class about setting up FOIL, setting up A times C, a couple of things that you can do to help you remember what you're going to be doing on each of the problems. So let's go ahead and go to the next one. Oh, if you wanted to check this, which I do highly recommend checking it, you're going to use the FOIL method. So remember where you do the first numbers, and then you do the outer numbers, distributive property here, and then you do the inner numbers, you multiply, and then the last numbers, so FOIL, to go ahead and check it. And your answer should end up like this. If it doesn't, you've either multiplied wrong or this answer is wrong. So if I were looking at this problem right here and I'm trying to help you and tell you how to set it up, I'm going to leave some space unless I need to, in case I need to factor something out. But I'm going to set up my page like this, and I know I need to multiply A times C. So what I'm going to do here first is look and see, is there anything that these might have in common? Okay, and I already see a mistake that I made that you may need to fix. There is no y here. There needs to be a y there. Sorry about that. Okay, I'm going to double check. 10x to the third, 36x squared y. Okay, so this is correct once you add your y. Otherwise, the problem wouldn't make sense, so I apologize. And so I'm looking in here and I'm seeing, do they have a greatest common factor that I can factor out of a number? 10, 36, 16. Now they're all even. So I'm going to take my 10 and I'm just going to think in my head, the factors of 10 are 1, 2, 5, and 10. So I'm going to see, do any of these have, obviously they have 1. They both have 2 in common. They do not have 5, and they do not have 10. So my greatest common factor of these three numbers is 2. So I'm going to pull out the 2. Then I look, is there any variable or letter that they all have in common? They all have at least one x. Now this one has x squared, so 2x's essentially, and this one has x to the third power cubed. But they all at least have one x. So I'm going to factor out 2x out of it. Now that's the same as, remember, dividing. This is where it kind of starts to look messy, so I apologize. I didn't leave myself quite enough room. And then let's see, so that would be 5x squared. And that would be 18xy and 8y squared. And now I'm ready to start. So if you recall from math on Monday, that 2x is going to remain on the outside every single time we have parentheses. It is out. We've already factored it out, or just kind of in like everyday terms, not math terms. We've taken the 2x out of each of these right here. So it needs to remain outside of the parentheses. We've already taken it out. Mathematically speaking, it's called factoring. We've factored it out. So then we're going to look at our A and our C. This is our A, 5, and our C is 8. So we're going to look at 5 times 8, which gives us 40. So we need to think, what are all the factor pairs that we can get for, well, actually it's negative 40, sorry, because this is a negative 8. So what are all the factor pairs we can get for negative 40? So we can multiply 5 and a negative 8. We can multiply a negative 5 and an 8. Now, I want to kind of show you something so that you don't necessarily have to write out all of them. You can write out all of them if you want to. And if you're struggling with this, I highly recommend writing out all of these. But if you keep in mind that you're looking for a negative 18, or just even think of 18 right now. Maybe you don't even think of the negative sign. Just think of 18. What would be 2 factors that you can multiply to get 40 that are somehow going to get you 18, whether you add them or subtract them? So 5 and 8, that's only going to give us like somewhere around like negative 3. That's going to get us 3. So then I start thinking 2 and 20 are both factors here. So I have to have a negative 2 and a positive 20, because remember, when I multiply them, they need to be a negative 40. Or I can have a 2 and a negative 20. And then I'm going to stop because I'm looking for the negative 18. These ones I already know aren't going to cut it. This is going to be a positive 18. This is going to be a negative 18 when I add them up. And this is what I need. I need it to be negative 18 to match this second term here. So that means that these two are going to be the O and the I. So I look at the first one, which is 5x squared. And then my O and my I, we've got a 2 and a negative 20. So it's going to be plus 2xy minus 20xy. And then my last one, minus 8y squared. And then I'm back to factoring by grouping here. So I look at this first set, this first binomial here, and they both have an x in common. So I can go ahead and take out that. Now remember, I have the 2x here already, so I do need to go ahead and remember that that 2x is on the outside here. And then I'm going to factor out an x, so I'm probably going to have to put a bracket because I know I'm going to have parentheses in here. And actually, let me just show you. This might even confuse you. I'm sorry if it does, but I'm going to rewrite it with the 2x out here. Instead of relying on you remembering that we factored it out up here. And now I'm going to group these two together. And then I'm going to group these two together. So that makes these need to be brackets. Remember, you wouldn't have parentheses. Like in math, you're not going to have parentheses on parentheses. So this is going to turn into a bracket. I just want you to remember that 2x is going to be on the outside of it. So now I'm looking to these two. So I'm going to factor out an x from that. So if I'm dividing this by an x and this by an x, I'm left with 5x plus 2y. And then out of this, they both have a y and also 4. is the greatest common factor of 8 and 20. Now, I can do 2, but that's not going to be accurate. You need to take the greatest common factor. The greatest common factor of 8, -8, and -20 is going to be -4. So I'm going to go ahead and take that out. So if I divide both by 4y, -4y, I'm going to get 5. The y's cancel out, so I just have an x. That equals a +2. And 1y cancels out, so I'm left with that. And they both have this in common. So again, I'm transferring down the 2x that we factored out from the very, very beginning. And then it's going to be times 5x plus 2y. So we just took those both out, and then we have an x minus 4y. And that's your answer. I understand this is a lot. It's a lot of steps to get it. This is why showing your work in math is extremely important. And you'll notice that when you start doing your work, I'm not just going to give you 1 point for this, like right or wrong. You may get all the way to this point and then you mess up here and get something wrong. But I'm going to give you credit for the few parts that you did correctly. So you want to make sure that you show all of your work so that when I'm grading it and looking at it, I can see you're on the right track. Did you make a silly mistake in adding or subtracting or dividing? Or did you make a mistake that because you really don't understand the concept of what you're doing? So I always say you need to show your work. I want to see it when I'm grading it, even if it's on a separate piece of paper. If you write answers on one paper, but then you have your work on another paper, I want to be able to see it. It needs to be legible and it needs to be numbered. So I can see, for example, like this work would have gone with B. I need to see that also. So if I just see this, I'm only giving you partial credit. So make sure that you show me all the work. Now, if you have a parent that really enjoys math and is good at math and has shown you a slightly different way to do it, that's fine. That's completely fine. I still want to see the work that you did for it. So if you don't write out FOIL, and you don't have to write out FOIL, if that doesn't help you and you don't understand that, or it's just something you don't need to do because you already know the concept, then don't do it. But if you are struggling, I highly recommend you write the FOIL and the A and the C. Okay, look back in your book. Both of these are in your book, and your problems will be very similar to this. So that wraps up lesson 7.5. These are the notes for lesson 7.6, special factoring cases, and I really like this one, and I'm hoping that you do too. But when you're factoring polynomials, there are actually 2 different special cases where you can use a shortcut. And it's just one of those things like where you just have to be able to recognize it, and then you can factor it as a shortcut. So the first one, don't you love shortcuts? I love shortcuts when it works out and doesn't make it seem like I'm being lazy. And in this case, it's not. It's being aware of something. So the first shortcut is called a perfect square trinomial. And that's like this: a plus b squared. That's a perfect square trinomial. Well, this is the perfect square trinomial. This is what it looks like factored. So you have a squared plus 2ab plus b squared. So here are the determining factors. It has to have this in order to be a perfect square trinomial. The first and the last terms must be positive perfect squares. Okay, so the first and the last term are both positive, and they're both perfect squares. They're 1. 1 times 1 is 1. So that is a perfect square. A perfect square is like 4, because 2 times 2 is 4. 5 would not be a perfect square because there's not a whole number that you can multiply by itself to get 5. So if you think of 4 and then 9, because that's 3 and 3. So if these 2 added up to that, you could do it that way. So it just needs to be where the first and the last terms must be positive perfect squares. So we've got a 1 and a 1. Those are positive perfect squares. And then also the middle term, which in this case is plus 2ab, must be twice the product of the square roots of the first and the last. So the first and the last here in this case are 1. So that middle term must be twice that. 1 times 1 is 1. And when you double that, because it says twice, so times 2, you get 2. So let's go ahead and kind of dive into this and see what we can do. And then this is extremely important, which is why I put 2 little stars by it. Remember, when you're using any factoring method, it's really important to first check for and factor out any common monomials, because you might not be able to identify that it's a perfect square unless you factor something out of it. And that's going to be the case on B, not on A, but B. So I'll show you that. So maybe I'll just draw an arrow here, because really this one is going to refer to this, but I want to be able to show you that. So let's look at our first example, 7.6a in your book. So the way that we can tell, we're going to factor out any common monomials, which they do not have any. There are no common monomial. And then we're going to check for the perfect square trinomial pattern. So the first and the last terms are positive perfect squares. So in this case, remember, no number there like this means it's a 1. That's a perfect square. And 16 is a perfect square because it would be 4. And then the middle term is going to be twice that. So here's kind of what I mean by that. So we're going to check for, on this one right here, that would be x squared. That's going to be x like that. X to the second power, or x times itself. Then 16 is going to be, this is how we know they are perfect squares. If there's a number that can go inside this parentheses, or in this case, the variable, that's going to be squared and equals that number, then it's what you call a perfect square. So check and check on this first one right here. The first and last terms must be positive. Then we have the middle term is twice the product. So if we took 4 and x, so I'm taking the x here and the 4 here, not the square, but just, this was just checking to see if they're perfect squares. But I'm taking what would be the square of it, which is an x and a 4, and I'm going to double that, which is the same as multiplying it by 2. I should get this middle here. 2 times 4, 8 times x, 8x. And so, yes, that equals 8x right there. So then what I'm going to do is write out, from there, you know it's going to be the x and the 4, because that's what you factored out. It would end up being this. If you I'm sorry, I just realized on the screen you couldn't see it. Sorry. It would be x minus 4 times x minus 4, which is the same as writing it like this. Now, I realize that is, to me, seems easier than I'm sure it was to you. So I want you to just kind of look over this, and I'll just real quickly try and go over it. So first of all, there was no common monomial, so we got to jump right in it. We wanted to make sure that the first and the last, and I'm taking it from this part right here, the first and the last terms are positive perfect squares. They were x squared and 16. In order to get x squared, you would do x times 2 or squared. And then 16 is the same as 4 squared. So it checks that they are perfect squares. Then we're going to take those two, the x and the 4, and we're going to double it, which is multiplying it by 2, and we get 8x. And that's what we have as our second term there. So the middle term there must be twice the product of the square roots. These are the square roots, the x and the 4, times 2, 8x, 8x. So then it checks out. So then what we're able to do is just write out the factored form. Now, excuse me, another way that you can, if you're having trouble remembering, like, what are my 4's going to be here, or what are my numbers going to be here, look at 16. What is the square root of 16 is 4, so that is what is going out here, a 4 and a 4. And if you were to FOIL method this, you would get this answer right here. So when you identify it, if you run these two little things through your head real quickly, it's almost as if you wouldn't even need to show work. That's why they're shortcuts. You would be able to look at them and just determine automatically that this is the answer. So you really wouldn't even need to show any work there. Now on this one, that's not the case. On this example B, you are going to need to show some amount of work because they have some things in here that they have in common. So there are common monomials. We're going to factor out a 2x from each of these. And I do think this is one of the easiest ways for any of you that struggle with how to factor out or take out a 2x from each is to divide each term by a 2x. So if we were to divide this, we would get x squared. If we were to divide this, we would get plus 2x. Oh wait, did I forget the y? My, oh my, oh my. I'm sorry about that. Could you add that y in there? I don't know why I keep forgetting that. Probably because look how much I have to do. You have to push all these buttons, separate little buttons, and with the mouse in order to get exponents on this. And so sometimes I get thrown off when I do that. I apologize for that. So this should be a y there. So when I go ahead and I factor out that, I end up getting a 2xy. And then those factor out and I get a y squared. Okay, so the first thing here, I factored it out. I factored 2x out of it all. So now I look at this one and I determine, is this a perfect square trinomial? Remember, it's trinomial because there are 3 terms, 1, 2, 3, trinomial. So if there's just 2, it's a binomial. If it's 1, it's a term or a monomial. And then if there are more than 3, it's a polynomial. So with this trinomial that we have here, I'm going to run through the little checkoff list up here. First and last must be perfect squares. So that would be x squared. Yes, because I can do x and square it. And then y squared would be that. So yes, I can, that checks that. These are perfect squares. And then I'm going to do the second part, which is the middle term must be twice the product. So x, because remember I'm multiplying those. That was the product of the square root. The square root of this was x. The square root of this is y. And I'm going to double that or multiply it by 2. It says it needs to be twice the product. So that's going to equal 2xy. I'm not going up to here because I factored something out. I'm going here, the middle term, 2xy, 2xy. So that automatically tells me that it is a perfect square trinomial. Now I don't want to forget this 2x that I factored out of here. So the 2x needs to go out. Now if you, this is so much work here. So if you're worried you're going to forget that, maybe take a highlighter and highlight it so you remember at your answer, at the very end of your answer, you need to factor out, or you've already factored it, you need to write it out again. So the 2x, you need to write that 2x, and then I'm going to write it as the perfect square, which in this case would be x plus y squared. So I'm taking this and this, the square roots of those, and that's what's going on in the inside here. Just like I took on this problem, I took the square root of this and the square root of this, and that's what went in here, square root, square root. Now, the one thing that I kind of didn't really go over that you'll need to double check, because in this one you may have realized that this one is a negative or subtraction and this is a positive. That's just determined by your signs. So you need to double check on what that sign is. If this is a a subtraction here, then put a subtraction there. If this is addition here, put an addition here. If this is subtraction, you can't do it. So this right here is your answer to this problem. And I didn't do this, but this is the answer to that problem. Move this up a little. So I want you to see that this was originally factored out from the problem, so it is part of the answer. So when you factor something out like that, you can highlight it to remind you that it needs to go here. So this one you would have needed to show work. For this one, you would have needed to show this part, showing me that you're factoring it out, and then of course your answer. So like this problem would have been worth 2 points, whereas this problem, if you didn't need to show the work, would just be worth one point there. For the last example, or in what we were doing in the last shortcut for this is called difference of squares. So this is our second one, a difference of squares. So the first one was the perfect square trinomial, and you could recognize that. And this one's called a difference of squares. So you'll notice that it's a plus b, a minus b. So the second factoring shortcut's related to conjugates. Now, chapter 6 is where we talked about that. And conjugates are binomials, so one term, two term, one term, two term. So these are two separate binomials. And the only thing that is different with them is the sign. One is a positive and one is a negative, or one is addition and one is subtraction. So when you write your answer, it ends up like this. So what we're going to look at is how you can determine that. Oh, and by the way, I also wanted to share that when conjugates are multiplied, so when these two are multiplied, you only are using the F and the L, because the O and the I end up being additive inverses. In other words, they cancel each other out. So it might be like plus 2x minus 2x. That's going to cancel out. Or it might be plus 3xy minus 3xy. They're going to cancel each other out. So your answer only ends up being using the F and the I. So let's go ahead and look at this first example here. And again, there are rules to this. Both terms must be perfect squares. The operation between them must be subtraction. Okay, so let's look. I think this one is the easiest to check for first. Subtraction, yes. I'm going to look at this one too. Subtraction, yes. Okay, now let's look at these two terms. The term 4 and 25. Are they perfect squares? And the answer is yes. So they are perfect squares. So I wanted to show you that. Now, in this one, what I didn't include was the x, and you can put that in there too. If this were an x squared, this would end up being an x. So I probably should have included that, I'm sorry, in the whole entire term, 4x squared. So the 4x squared, the perfect square of that is 2x. The perfect square of 25 is 5. So I wanted to go ahead and go over that. So this is going to seem a little bit too easy to you, but if you write it out like this, basically this is your answer right here. You've just done your answer right here. It's 2x plus 5 and a 2x minus 5. Because remember, the O and the I are going to end up canceling each other out, which is why you end up with an answer like this. So it doesn't mean you don't have the O and the I like when you're giving your answer here, but when if you were to do the FOIL method with this, the O and the I would cancel each other out. So this is your answer. So they're conjugates. The only thing that's different, they both have a 2x, they both have a 5 and a 5. The only thing that's different is the sign in between, addition, subtraction. So this would be your answer here. You can even go in, like I said, and check it with the FOIL method and see that it would end up being that. In fact, let's do that real quick. So if I do 2x plus 5 2x minus 5. So if I do first, that gives me 4x squared minus 10x. Then I do this, plus 10x and minus 25. So then when I combine those two, they cancel out, and I'm left with 4x squared minus 25. Which, as you can see in your notes, is the original problem. So then, I don't know, I always do it like this. Oh, check. So that just shows me like you went ahead and you checked it. So this is the answer. So the O and the I right in here, this is the first, the last, the O and the I, and they end up canceling out, only leaving you with these two. So that's what I meant by that answer. Okay, let's go ahead and take a look at B. So we're going to factor out any common monomials, and by the way, there was no common monomial here, so we didn't pre-factor anything out. On this one, there is, because the greatest common factor of 9 and 36 is 9. So we're going to factor 9 out from that. Divide by 9, divide by 9. Now, again, if you're worried you're going to forget this 9 in the answer, then highlight it as just a little, hey, remember me. So this ends up being x squared minus 4y squared. And we already looked over to see if this one followed the operation between them must be subtraction. It is subtraction. So let's look and see if both terms are perfect squares. So we're not counting the 9. We've already factored that out. So x squared, that would be x. For 4y squared, that would be 2y. And if you do it like this, you take these two terms like that, and you find what the perfect square is, then you have your answer right in here. Because your answer, don't forget your 9 on the outside, would be x, and it doesn't matter to me which way you put it, plus 2y, and then x minus 2y. I do think that this is a little bit easier than the 7.5 lesson. It seems almost too easy to be true. If you follow every single step that I've done here, then you will be able to find your answers much easier, because you'll notice that these are your answers, an x and a 2 and a 2y, x and a 2y. And if you remember on the difference of squares, difference meaning subtraction, that has to be a subtraction there. And then each of these has to be a perfect square. So here are some other perfect squares, just in case. Let's see. So we have 4, 9, let's see, 12, 16, 25, because this is 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. So you can probably guess what the next one is, 36. It's going to be 6. So these numbers, these two numbers, or once you factor it out, you wouldn't even be able to look at this. There is no perfect square. Oh, sorry. Yes, there is a perfect square for 6. But we factored the 9 out of it first. If that were a different number other than 36 and it wasn't a perfect square, because both terms must be a perfect square. So in this case, 9 and 36 are, but also in here we've got x squared and 4y squared. So they are perfect squares. Okay, let's go ahead and see, let's do a problem from the book. I'm not even sure, I don't have open my list of what you're supposed to be doing for your work today, so you might luck out and I might pick one that ends up being one of the ones you were supposed to do in your work today. Let's see, okay, we're gonna do, this is 23, and it's actually, you're just writing a yes or a no, but that's usually going to mean that you might have to solve it. So the problem is 16x squared minus 49. And the directions read, determine whether each binomial can be factored as a difference of squares. So we're going to look at this. Remember, our two things were, and I do them backwards. Is there a subtraction problem? Yes, it is subtraction. And then are these two terms perfect squares? Well, if you look back over here, and this might not even be something, this might be something good to even write down so that you can easily identify. Maybe go all the way up to 10 or maybe even to 12. So you can just easily identify this. These are all perfect squares. So if we look at 16, yes, 16 is a perfect square, but I like to write it out, and I encourage you to write it out, 16x squared, and that would be 4x, because if I put this like this, that would get me that answer right there. So that's why you can either write it like this, or you can write it like I am with the radical sign. And then you have 49. And if you have your list, because you're unsure, you could see that that would be 7. And then you have your answer, 4x and 7. So remember, you have 4x plus 7, 4x minus 7. And that would be the answer. Although in your book, I think it just says write yes or no. Determine if each binomial can be factored as a difference of squares. So in this case, 23 would be yes, and you know that because you were just able to do it right here. Now let's take one. I'm looking to see if there's one that we can do just real quickly. Okay, let's do 27, because I want to show you what happens if not. So just spoiler alert, this answer would be no. So let's do all of these ones that we've done so far. You've been able to factor them using the difference of squares shortcut by recognizing it. So you would look at this problem and you're going to recognize it. Okay, remember there's step 1 and step 2. Step 2 is the easiest. Are they separated by a subtraction? Yes. Number 1, are both of these a perfect square? So you would write out like this. Okay, yes, so far. Is there any whole number that you can multiply by itself to get an 8? And there is not. And if you made your little list here, you would see there is no 8. It jumps from 4 to 9. So this answer would be no on this one. So 27 in your book, I just gave it to you. It's no, but I want you to understand why. Because there is no perfect square for 8. Just like there was here. X, this would be like that. Would give you that number. There's no number that can go inside this parentheses that when you multiply it by itself will give you an 8. So this answer would be no on that. Okay, I hope that helps. That's a whole lot of talking for just 2 problems, but I wanted to make sure that I try and speak very slowly and carefully on everything that I go over. So I'm sorry if for some of you you're like, I get it, just move on. But just remember, you're not the only one watching these videos, so hopefully it was helpful for somebody else. Also, I wanted to point out, I'm not sure if you're familiar with Khan Academy. I'm sure you probably are, but just in case, I'm going to write it down right here. Khan Academy is an excellent math source, and I have maybe even told you about it before, but I can't remember if I told this year's math class or if I talked to last year or what. But Khan Academy is an excellent site that has all kinds of videos. It's free, by the way. I will try and remember to link, to put a link in the description for Khan Academy here. If I can find the one that even talks about these ones right here, the difference of squares, and to help you, because maybe the other person can explain it in a better way. So if you're still struggling, I recommend looking up or clicking on the link if I left it to Khan Academy and watching that to see if you can understand it a little better. Okay, that ends 7.6. Reach out if you need anything.